Myself Hiren Patel, Assistant Professor at LJ Institute of Engineering and Technology. In this current video lecture series, we are studying subject of Physics Group 1. So, in this chapter, in previous videos, we have discussed about concept of load, types of load, concept of stress and strain along with Hooke's law, and working stress and factor of safety. So, now in this video we will learn the topic such as elastic behavior of solids, factors affecting elasticity, types of elasticity, and types of elastic modulus. So let's start with the first topic of today's session, that is elastic behavior of solids. So the property of material to regain its original condition on removal of deforming forces is called elasticity. So in last video we have discussed about the elasticity property. So different solid exhibits three types of behavior when they are subjected to elastic loading, which we are going to discuss. So, let's start with the first point, that is elastic after effect. So, when a body is subjected to tensile load, then it is expected that body will gain its original position after unloading. We know that this is ideal condition, but actually this process of regaining original position is not instantaneous. It will take some time. So few materials take some time to regain its original position. That delay in coming back to original position is known as elastic after effect. So, again, when body is subjected to a load, it will gain its original position after unloading. But the time to regain its original position, it means that the delay in coming back to original position is termed as elastic after effect. So, this elastic after effect is very short for material like quartz. So now, next is elastic fatigue. So, as we know that when an elastic body is loaded within elastic limit and kept strained for some time, extensor is producing it, and on removal of load, it is expected to regain its size. But if such elastic body is subjected to this type of loading and unloading conditions, then it becomes less elastic. So it is the phenomena behind it. So now, due to continuous alternate strains, the elastic body becomes fatigue. This phenomena is known as elastic fatigue. Now, so a body under this kind of repetitive alternate loading will break under a stress less than its normal breaking stress, even within its elastic limit. Again, I repeat that sentence. If elastic body is subjected to this type of loading and unloading conditions, then it becomes less elastic. So due to continuous alternate strains, the elastic body becomes fatigue. This phenomena is known as elastic fatigue. Next, when elastic material is subjected to stress, it will develop a strain. So we can plot the stress strain diagram during loading path as well as unloading path. So this is the process behind that third property which we are going to discuss, that is elastic hysteresis. So when unloading is carried out, it is expected that strain will follow the reverse path to reach the original zero strain position, which it is followed during loading condition. You can see in the figure here, but material follows entirely different path to reach zero strain position while unloading. So what will happen? There will be two different curves on the stress strain diagram. You can see in the figure. So here, this phenomena in which material observe two different stress strain diagram is termed as elastic hysteresis. This is the reason why the values of strain for some stress are different while increasing the load and decreasing the load. This hysteresis concept is somehow related with that magnetic hysteresis concept. Here, the area under the curve of stress strain diagram is called hysteresis loop, and it is numerically equal to work done in loading the material and unloading it. So here, in this elastic hysteresis effect, we can observe two different stress strain diagrams in the figure. So this is the concept of elastic hysteresis. Now, next topic is factors affecting elasticity. So the first is effect of stress. A material loses its elastic property even within its elastic limit if it is subjected to a large number of cycles of stress. So we can say that after being in its elastic limit, if we subject a large number of stress, then material can lose its elastic property. Now, next is effect of annealing. So we know that annealing process increases the ductility in the material. In last video, we have discussed about that ductility property and ductile materials. The process of annealing decreases the elastic properties of materials due to the formation of large crystal grains. So here we can say that due to annealing, if annealing decreases, the elastic property of material also depends on this property. Now, next factor is effect of hammering and rolling. So, hammering and rolling breaks up the crystal into small units, and hence these processes increases the elasticity of material. It obvious thing that if material divided into or a crystal divided into small units, then elasticity of that material is going to increase. Next factor is effect of temperature. The plastic properties of a material decreases with the increasing temperature. Here we can say that elastic material is also depend on temperature. Now, next is effect of impurities. So the elastic properties of materials depends on the percentage of impurities added in that material. So the increase or decrease in the elastic properties depends upon the types of impurity added to it. Here we can take an example. When the potential added to the gold, elastic properties of gold increases. So we can say that elastic property of material depends on that impurity which will be added in that material. So these are the factors affecting the elasticity. Now, next we are going to discuss is the types of elasticity. So we will start with the first type, that is elasticity of extension. Here in this case, the force which produces changes in the length of member or material, the material regains its original shape after removal of that force. It is also called as elasticity of extension. We have discussed that two phenomena, tension and compression. We know that deformation due to tension results in increasing the length of material. Same way, in case of compression, the length of material will be decreases. So this is the elasticity of extension. Now, next type is volume elasticity, or it is also known as bulk elasticity. So when body subjected to forces produces the change in volume, so body regains its original shape after removal that forces. Such body we can say that it experiences the volume elasticity. You can see in the figure, after applying forces to the body, the volume will be decreases. Here we can say that here change in volume occurs in case of that volume elasticity. Now, last type is elasticity of rigidity. So the force which causes the deformation in the consecutive horizontal layers of an object relative to one another. Here we can say that the orientation of the sample will change. So here when the deforming force is removed, the body regains to its original shape. So at that time, that elasticity is known as elasticity of rigidity. So these are the types of elasticity. Now, we are going to discuss the types of elastic modulus. So there are three types of elastic moduli. First is Young's modulus, second is bulk modulus, and third is modulus of rigidity. So we will start with the first modulus, that is Young's modulus. So it is defined as the ratio of longitudinal stress to the longitudinal strain. Here we know that longitudinal stress is given by ratio of force to cross-sectional area, and longitudinal strain is given by ratio of change in length to original length. So here, if load is applied to a wire of length L and cross-sectional area A, then we can define the Young's modulus as Y equals to F by A upon delta L by L, where F by A stands for longitudinal stress and delta L by L stands for longitudinal strain. So we can replace F is equals to M into G in place of force. So finally we have the equation of Young modulus, Y is equals to small m into G L upon A into delta L. Here it is obviously that your unit of Young's modulus is Newton per meter square, or we can say it as a Pascal. So next modulus is bulk modulus. Here we can say that bulk modulus is nothing but the ratio of volumetric strains to the volumetric strain. Here, same way. Here if we are discussing about that bulk modulus, so obviously there is a volume involved. So here volumetric strain is given by change in volume to original volume. So here, if load is applied to a substance, then only a change in volume will be there. So the volumetric stress is nothing but the pressure. So here we can define bulk modulus as ratio of pressure to volumetric strain. Unit of bulk modulus is also Newton per meter square. Now, the last modulus is modulus of rigidity. It is defined as ratio of shearing stress to shearing strain. Here, if tangential load is applied to the surface of substance, then the shape of substance will change. This concept we have discussed in shearing stress and shearing stress. In this case, the orientation of that sample or orientation of material will change. So here we can define that modulus of rigidity as ratio of force per area, which indicates the shearing stress, to the shearing strain, which is given by theta. So finally we have modulus of rigidity, eta is equals to F by A theta. So in this video we have discussed the elastic behavior of solid, factors affecting elasticity, types of elasticity, and at last we have discussed the various types of elastic moduli. So now in the next video we will learn to calculate the time period of torsional pendulum and the equation of work done in stretching the wire. So that's it for today's session. Thanks for watching.